Hey. Hi, my name is City, and today I want to talk about the hidden cost of AI and how AI is creating global energy demand. First, think about how many times you've used AI today. Maybe you use ChatGPT, maybe you use Google, or maybe you even use voice assistants. It feels instant, simple, and almost even free for most of the time. But what most people don't realize is that every time you use AI, it requires real electricity, sometimes a lot of it. So today, I want to talk about the hidden cost of AI and how AI is creating global energy demand. First, I'll talk about how fast AI is growing and why that matters for you. Second, I'll talk about how AI actually uses the energy behind the scenes. And thirdly, I'll talk about what companies are doing to make AI even more efficient. First, let's start with how fast this is growing. According to the International Energy Agency, electricity usage in data centers is growing by about 17% in a single year. That's extremely fast compared to most industries. The main reason of because of this expansion, the main reason for this is because of expansions of the different AI systems like ChatGPT, Claude, and Gemini. Different AI frameworks that are very common amongst common users today. So even though AI feels lightweight, it actually depends on the massive infrastructure that's happening behind the scenes that's consuming a bunch of energy. Another way to understand this growth is by looking at investment. Companies are investing heavily in AI, and that investment is increasing very quickly. This graph shows that AI spending is expected to almost double in a very short period of time. This matters because more investment means more servers, more computing power, and ultimately more electricity usage. So AI growth is not slowing down, rather, it's accelerating. So, what does this mean for energy demand? This chart shows that data center electricity demand is increasing much faster than overall electricity demand. That means that AI is becoming one of the fastest growing contributors to global energy usage. So even if the other sectors stay stable, AI alone is pushing that demand higher and higher. This is creating a pressure on energy systems and is helping to raise concerns about sustainability, with data center electricity even going to excess 900 TWh. Now, it's important to add some context. Right now, data centers are using less electricity than other sectors, like the industrial sector, the residential sector, and the transportation sector. But the issue right now is growth rate. They're growing at about 17% each year, which is a lot faster than all the other sectors. So even though they're small today, they're growing fast enough to become a major issue in the future. 5 to 10 years from now, they're going to lap all the other sectors and be much higher. Now, to truly understand what this means, you first have to understand how AI actually works. So, first, it'll take a user. Now, that user could be anonymous, it could be logged in, it could be creating a new account, but regardless, if you're using AI, you're a user. It's going to send a request, and that request is going to go through the AI model that's sitting inside a data center. Now, this AI model is going to be doing a bunch of complex calculations using statistics and these powerful servers to compute those statistics, because AI is not logic based like a lot of people think it is. It is probability based. So it's always computing the probability that the next letter that it gives in its output is the correct letter. And it'll take the highest probability of each possible output. And it'll do this for each single letter. So, as you can imagine, those servers that are computing these, they use a bunch of electricity, not just for the computing, but also for the cooling and maintaining the system, because all of these different computations will use electricity. And with all of this happening, you don't want it to catch fire and everything blows up. You want to keep it cool so that it can keep processing these requests. After that, the response will get sent back to the user. So even the most simplest of requests will trigger a chain of a bunch of energy consuming processes. So whether you're just asking a simple yes or no question or asking for an entire essay written for you, it's using a bunch of processing power. Now, that's only for one person. Now imagine millions of users doing this all at the same time. As you can imagine, the energy usage becomes very, very significant. But there are some good news. AI is becoming more and more efficient over time. Now, in the past, models were a lot bigger and they were much less optimized. But now, companies are improving the efficiency through better algorithms, better hardware, and smarter computing systems. That means that each AI task uses less and less energy than before. So while total usage is increasing, efficiency per task is improving. We can actually see this improvement with real numbers. For example, Microsoft has improved their data center efficiency by up to 93%, and Google has improved their cooling efficiency by 84%. These are major improvements, and they help show that technology is helping reduce energy usage even as AI continues to grow. But overall industry gains are still smaller, which means there's still a lot of work to do. To wrap it up, AI is growing rapidly and becoming more powerful every year. But with that growth comes increasing energy demand. See, the goal is not to stop AI, but rather is to make it more sustainable. That means improving the efficiency, reducing the waste, and designing better systems. At the end of the day, the future of AI depends not just on how powerful it becomes, but on how responsibly we use its energy. So, these are my citations for the presentation, and thank you for your time.